about inverse functions, okay? What does it mean for something to be inverted, or what does it mean to invert something you've done? What does it mean? English, this is not math. What does it mean? Huh? You undo. That's all this really means, is you're going to undo something. So every morning, I assume you wake up and there's a function, either a bus or a car or a train, that takes you from home to school. What would the inverse function do? It would take you from school to home. So basically, you end up where? Where you started, okay? So one function takes you from point A to point B. The inverse function is going to take you from where? Point B to point A. That's all an inverse function does, okay? So if I have an x, I can add 3 to it, and the x has changed to x plus 3. What would I have to do to undo what I just did? I would do what? I would subtract 3. So the inverse of adding 3 would be to subtract 3. Okay, that's pretty straightforward. Okay, let's look at that graphically. Okay, it looks a bit more complicated, but we'll get through it. Let's graph f of x equal x plus 3 and x minus 3 and see what these guys look like. So I want to graph x plus 3, and then I'm also going to graph x minus 3. So I'm just going to pick some points. Okay, what is negative 2 plus 3? 1. What is negative 1 plus 3? 2, 0 plus 3, 1 plus 3, and 2 plus 3. Okay? So if I graph these points, it's probably going to be the graph of a what? Straight line. Okay? So negative 2, 1 is, negative 2, 1 right there. Negative 1, 2, 0, 3, 1, 4, 2, 5. Okay? So that should be a straight line. Let's see if I can make it look like one. And this is where I battle some days with this smart board. So let's just see if I can move that to make it look a little bit neater. So make it go through these points. Something like that. Maybe a little bit closer. Okay, let's leave it right there. So that is the straight line of x plus 3. Okay. Now let's graph the line x minus 3. Okay. So let's see what we can do with that one. What is 1 minus 3? Negative 2. 2 minus 3, negative 1. 3 minus 3, 4 minus 3, 5 minus 3. So I get what? 1 negative 2, which is right here. And I get 2 negative 1, 3 0, 4 1, 5 2. Okay. So if I were to graph that line, that looks something like, let's just see if we go. And trying to get this to look a little right. There we go. Okay, not quite exact, but you sort of get the picture there. Okay. So I got these two lines. Okay. Now, if I were to draw this line that goes straight through the diagonal here, how did that happen? So let's draw the line that goes straight through this diagonal, something like that. Not a good example. Let me try it again. Okay, pretend that that's the diagonal, okay? So if you were to turn your head sort of sideways, it looks like these lines are symmetrical about the green line, okay? Earlier on, we talked about things being symmetrical about the y-axis. A function was what if it was symmetrical about the y-axis? It was what kind of function? Even. That was the word for it, okay? This is not symmetrical about the y-axis, but this green line, it looks like I've got parallel lines. It looks like if that green line was a mirror, those would be accurate reflections, okay? What do you notice about these points? Negative 2, 1, 1, negative 2. What do you notice? What? Yeah, it's just flipped, okay? He used the word inverse, okay? If negative 2 gives you a 1, The inverse would have to take a what? 1 and give you back a negative 2. Okay? If negative 1 produces a 2, the inverse function would have to take a 2 and give you a negative 1. So what's happening to the x and y values? They're what? They're just flipping. That's all that's happening. So the inverse, all it does is it flips the x and the y value. So it's just changing the role of x and y. So what we kind of symmetry we see that this is symmetrical about that line. That line that goes straight through the diagonal is y equal x. So inverse functions are symmetric about that line. Let's graph one more and look at its inverse and see what's happening. This is our parent function. We want to graph x cubed and the cube root of x. So x cubed and the cube root of x, okay? So this is a parent function. We already know what it looks like. What is the negative 2 cubed? Negative 8. Negative 1 cubed. It's negative 1. 0 cubed. 1 cubed. And 2 cubed. Okay? What is the cube root of negative 8? Negative 2. Cube root of negative 1. Cube root of 0. 1. Cube root of 8 is 2. Okay? So if I graph these functions, the first one goes through what? Negative 2, negative 8. So that's right down here. Okay. Negative 1, that's right here. 0, 0, 1, 1, 2, 8. Okay, we remember this function, x cubed. What do we call that? Was this the, what do we call this one? I don't even remember. The nene? Okay. So this function does something like this. That was x cubed. That's one that we already knew. Okay. Now, what was the cube root of x? It's going to go through negative 8, negative 2, negative 1, 1, 0, 0, 1, 1, and 8, 2, which is right here. That one we called, what do we call, freestyle? Is that what we called it or something? So we knew that that one did something like this, okay? So this is the cube root of x. Do those feel like inverse operations to cube something and then take the cube root? Yeah, I mean, you cube something, you take the cube root, you ended up back where you started. So this should be symmetrical. If you were to turn your head to the right, does it look like it is symmetrical? If there were a line going right through here, would it look like it's symmetrical about that line? Answer is yes, okay? If that red line were a mirror, this looks like these two functions are mirror images of each other. So that's what it looks like graphically to have an inverse function. And again, what you notice is, look at these points, negative 2, negative 8. The inverse has what corresponding point? Negative 8, negative 2. All that happens is, to get from here to here, you just flip the values. So it doesn't change until you get to there, you flip them, okay? So that's what it means to have an inverse graphically. X and Y have changed roles, okay? So the other thing we want to note is a notation here. When you see something like this, all this means is the inverse of f, okay? It doesn't mean negative exponent, okay? Math is famous for using the same notation to mean different things. It's like English. It's the context of the word. When you see something like that, it's not a negative exponent. It means the inverse function of f. That's all that really means, okay? So all that's going to happen is with inverses, my x and y values change roles. So how would we graph the inverse of this function, okay? So here's a function. What does its inverse look like? Remember earlier we did something like even and odd? You know, that was just like it has to be symmetrical. This is a little bit different. So to do this, what is this point right here? Negative what? Negative 8, 0. Okay. Okay, and what is this point right here? Negative 3, 5. So negative 3, 5. This point up here is negative 3, is it 8? And this point here is what, 1, 4? Okay, so I've identified those points. Okay, so if this point is on the graph, what point must be on its inverse? This is negative 8, 0. What point has to be there? Get 0, -8. So you switch the role of x and y. So the inverse, it looks like there's a closed circle here. So at 0, -8, I need a closed circle. Here's an open circle at -3, 5. Where would I need to draw an open circle on the inverse? 5, -3. So 5, -3 is right here. And then what would I do with those dots? I would connect these dots. Oops. I need to make sure I get back to that one being open. Okay. Now, if I handle this, pardon me? Yeah, because if -3, 5 is open, 5, -3 has to be open. Okay. Now, at -3, 8, I need to go find which point now? 8, -3, which is right here, closed circle. And then 1, 4, I need to go find which point? 4, 1, okay? And if you were to turn your head sideways, it does look symmetrical if you were to draw a line straight through that quadrant 1 and quadrant 3, okay? So that's what the inverse looks like graphically. You made a mistake, yeah. So it should be, so really the point is, all that happens for inverses is x and y change roles, okay? So if you can just flip the x and y's, you know, here I've got 2 lines. All I need is 2 points to connect a line. Just find these points, find their flipped values, and that's what you need to graph. Now let's do it graphically. It's a little bit harder to do it algebraically, but we're going to get through that, okay? Remember, what is the whole big premise of an inverse? X and y have done what? What do? They switch their roles. They invert, okay? So here's a function, f of x equal x cubed plus 1. Let's just write it like this. Y equal x cubed plus 1, okay? That's what the function looks like. What will be the property of its inverse? What will happen to x and y when I look at its inverse? Yeah, they switch roles. So for the inverse is going to look like this. Oh, sorry. X. So what I did was I interchanged the x and the y, okay? So if I change x and y, that's going to be what the inverse has to do. And now I need to solve this equation for what? Solve this for y. How do I solve this guy for y? Yeah, I need to get y by itself, so what's the first thing I would do? Subtract 1 from both sides. So I get x minus 1 equal y cubed. Okay, I'm trying to get y by itself. Y is being cubed. What could I do? Take the cube root of both sides. Okay, so then I would get the cube root of x minus 1 equal the cube root of y cubed. What's the cube root of y cubed? Y. Those are inverse things of each other, okay? So the cube root of y cubed, so this tells me that the cube root of x minus 1 equal y. So my inverse function is y equal cube root x minus 1. Your final step here is to write this in inverse notation. So f inverse is cube root x minus 1. That just means f inverse. It's just a notation that means f inverse. Okay. Now, let's write this in English. So you're trying to explain to someone who doesn't know math. Start with x. Describe in words what happens. Start with x. What is happening to x? You're cubing x, and then you're doing what? Adding 1. So this is you cube x and add 1, okay? That's in English, that is what is happening right there. Cubing x and adding 1, okay? So if I were to cube x and add 1, that takes me right over here. How could I undo that? How would I undo this to go back the other way? What would I have to do? Not add. How do I undo what I did? I would subtract 1, and then I would do what? No. How do you undo adding 1? You subtract 1. How do you undo cubing something? What's the undoing of a cube operation? No, cube root. If you add, you undo it by subtracting. If you multiply, you undo it by dividing. If you square, you undo by square root. If you cube, you undo by cube root. So to undo this, I cubed it and I added 1. To undo that would be to subtract 1 and take the cube root. Okay? Let's go down here. Tell me what happens here. Start with x, and in English, tell me what happens. Start with x and describe what happens. What happens to x? Start with x. How do we read? We read from left to right, don't we? Start with x and tell me what is happening. You're subtracting 1, and then what are you doing? Cube root. Okay, come on, guys. You're going to have to wake up. Even the earlier class. Subtract 1 and cube root. Okay. There we go. To cube it and add 1, to undo that is to subtract 1 and take the cube root. Okay. So don't they feel like it's like you went from home to school? How do you invert that? School don't. You just backtrack. So that's all we're doing is just backtracking that thing. So that's all the inverse function really does. Okay. So you're not going to have to do that description because I know you felt uncomfortable doing that. So no, you're not doing that description. Okay. So remember f of x. What do we say that was? Was x cubed plus 1. F inverse is, what did we say? It was the cube root x minus 1. What's the domain of f? Okay. In the domain, I'm always concerned about 2 things. What are they? Fractions and square roots. Do I see fractions or square roots in this? No. What's the domain? The inverse. I'm concerned about fractions or square roots. Do I see either? Which one do you see? Show me the square. Cube root. Those are different things. It's technically it's any even roots. So second root, fourth root, sixth root, but we're not getting to that level of difficulty.
So would it be the same?
Same thing, okay?
So it's only when we do, like, feels like, say it was x minus 1 squared?
Yeah, the square roots. I would have restrictions with square roots. Because remember, you can't take the square root of a negative number. Can you take the cube root of a negative number?
Yes.
All day long. There's not a restriction there, okay? So let's do another one of these guys. Find the inverse of 5 over x minus 2. Okay? So first step, write it like this. Y equal 5 over x minus 2. The big idea around the inverse is that what happens with x and y? They flip. So let's do that. X equal 5 over y minus 2. And now my goal is I need to solve that for y. What is the immediate thing that you don't like about that equation? It's a fraction. How do we get rid of the fraction? Yeah. If I multiply both sides by what? Y minus 2. If I can multiply both sides of that equation by y minus 2, right? That's valid. Is it okay? RNA's looking at me.
Wait, so you can't do
I can do what?
you can't multiply each side by like 5?
I could, but it's not going to help me because what is going to make it not a fraction is if that y minus 2 goes away. So multiply both sides by y minus 2. What happens on the right? Yeah. So I end up with x times y minus 2 equal 5. What am I solving for? Y. What's keeping that from being by itself? The x. So what am I going to divide by now? Divide both sides by x. Yes. Yes. Okay. So this is going to give me what happens on the left. Yeah. Y minus 2 equal 5 over x. Okay. How do I get y by itself now? Add 2 to both sides. So y is equal to 5 over x plus 2. Okay, that's my inverse. I need to write it in inverse notation. So f inverse is 5 over x plus 2.
So would you never plug it back into the original equation?
No, these are different equations. So this is my original function. This is a whole different function. It's inverse. Okay, and that's why I always change the color. I switched x and y, and I have a new function. So I've got the original function. Here's my original, and here's its inverse. Okay. Now, there are domain restrictions on the original problem. Okay. What is concerning here, a fraction or a square root? A fraction. I can never divide by? No. I can never divide by 0. Okay. So what would make this thing dividing by 0 when x is what? 2. So x cannot be 2. How do I write in domain notation x cannot be 2? Yeah, negative infinity to 2 and 2 to infinity. That's the domain of f. Okay. Now look at its inverse. Are there any problems with its inverse? Where would it be undefined? If x were 0, this is undefined. So x cannot be 0 in the inverse. How do I write x cannot be 0? In interval notation. X cannot be 0. What is it? Yeah, negative infinity to 0 and 0 to infinity. Okay. So the domain of f is negative infinity to 2, 2 to infinity. The domain of the inverse is negative infinity to 0 and 0 to infinity. Okay?
Wait, why? Did you say something?
Because if you look at f, this is f. When I look at f, x minus 2 cannot be 0. So x cannot be 2. That makes it undefined. Okay. So that means that if x cannot be 2, the domain of f is negative infinity to 2 and 2 to infinity. And then when I look at the inverse, right here, x cannot be equal to 0. That makes this undefined. So if x cannot be 0, this is what x has to be. Okay? So this domain and range skills, we've been working on those. They have to stay with us. Okay? So at this point, you should be able to draw the graph of an inverse. If I give you a graph, draw its inverse. You know that this notation, f superscript -1, that just means f inverse. And then algebraically, what we just did, you write the function y equals some expression, change the role of x and y, and solve for y. Okay. Now, one thing I think I did forget. Let me go back to the first page. I just skipped over it for some reason. I mean, you know this, but just to drill this home, what's the inverse of multiplying? Yeah, divide. What's the inverse of squaring? Yeah, square root. Inverse of adding? Subtract. Inverse of subtracting is to add. Inverse of dividing is to multiply. Inverse of cube root is to cube something. Okay? So these are just operations that you know already on some level. Okay? Now we're going to talk a little bit more about this later in subsequent lessons, but we need to talk about what it means for something to be a function. Let's look at a graph of something real quick and do it that way first. If I look at this graph, this is not a function because of something called a vertical line test. What does that mean? Have you seen that before? If I can draw a vertical line and it does what? Yeah. If it hits that graph more than one place, this is the graph of something that is not a function. Okay, so this is not a function because it hits the graph in two different places. So what that means is, if you look at several places, but if you plug in a 5, you're going to get a 3 and a -3. You can't get two answers back, two different answers. Okay, So when you plug in a number for a function, you only get one answer back. So this is not a function. So in the homework, we're going to do a couple examples where they ask us if something is a function. So let's do another example here of finding an inverse. Okay. What's the first step? I write this as what? Write what? Y equal 1 over x plus 1. The whole big idea of inverse is what happens to my x and my y. They switch places. So let's make them switch places. X equal 1 over y plus 1. Now it becomes an exercise of solving for which of those variables? Y. How am I going to do that? I need to get y by itself, so what's the first thing I'm going to do? Subtract 1 from both sides. So that gives me what? X minus 1 equal 1 over y. Okay, what is it I don't like? Yeah, so what can I do? I can multiply both sides of this equation by what? By y. Okay. So if I multiply both sides of that equation by y, I get y times x minus 1 equal what? 1. And then what do I do? No. I want to get y by itself. The problem is y is being what? It is being multiplied by something, right? So I got to do a dividing. So what do I divide by? No. DA, you got to wake up over there. I'm trying to get y by itself. What's keeping y from being by itself? It's multiplied by x minus 1. So I'm going to divide by x minus 1. So what's the answer here? 1 over x minus 1. And then your final step, write that in inverse notation. So y is equal to 1 over x minus 1. Now let's look at the domains of these guys. So you've got now if when you write it in function notation, it's just f inverse, okay? No. It's just easier algebraically to use the y when we do this manipulation. So first of all, what is the domain of this guy right here? First of all, what can x not be? X cannot be what? 0. How do I write the domain then? To 0? 0 to infinity, okay. And then if you look at the inverse down here, x cannot be what? 1. So how do I write this domain? Yeah. So it's negative infinity, negative 1, negative 1 to infinity. Okay. Oh, you're right. It's the problem is x cannot be 1. Thanks for that. So it's negative infinity to 1. X cannot be 1, so it's negative infinity to 1, 1 to infinity. Okay, how does this feel? Is this okay? It's feeling a little bit slow for Friday, but we'll get there. Here I give you the graph of x to x plus 4 cubed plus 1, and I want to see what its inverse is. Okay, so in order to graph its inverse, okay, I've got to find some points. What is this purple point right here? Negative 3, 2. Okay. So on the inverse, what point do I need to go find? 2, negative 3, which is right here. Okay. What is that blue point that you see right there? Yeah, negative 4, 1. So I need to go find what point? 1, negative 4. Okay. And then the green point is what? Negative 5, 0. So I need to go find what point? 0, negative 5. Okay. So I see these points, but I'm just not quite sure how to do it. Okay. Let's go find a couple points. This is roughly what? Like negative 210 way up here. Does that look about like negative 210? If that's negative 210, what do I need to be looking for? 10, negative 2. So it needs to head off about right there. Okay. And this, pardon me? Pardon me? No, if I come over to -2, it looks like I'm hitting about 10 right there. Something. And then if I look down here, this looked like about -610 is roughly where this is. So if this is about -610, what do I need to be looking for? It's -6, -6, -10, -10, -6. So -10, -6 is about right here. Okay. So -10. So is that right? -6, -10 is about -10, -6. So what is this guy doing? Y'all not with me?
Wait, you said -6,
What do you think? Somebody tell me what they think this point is.
No, I'm agreeing with you, but like it'll go to the what?
No?
It'll be so that point of the inverse will go to what? 10-6.
This feels like -6, -10. Prove me wrong.
Yeah. The
Okay.
inverse will go to 10-6.
If this is -6, -10, what would the inverse need to be looking for? -10, -6, which is about right here. Huh? I've got it. Now I'm going to draw the inverse. Come on, guys. So that's the inverse. Okay? If you were to turn your head to the right, does it look symmetrical? Tell me it doesn't look symmetrical about that green line. Come on. Yeah. So if I turn my head to the right, if the green line is a mirror, that looks symmetrical. Okay? Okay. What I'm saying is when I just plotted these 3 points, if I had these 3 points, I didn't know enough to know what to do. I mean, do I do this? I didn't know what to do. So I just looked at my graph and said, well, -2 is heading up to 10, so 10 needs to be heading to -2. Okay? So it's just changing the roles. Come on, guys, you can stay with this, okay? What I need to do, guys, I need to work you through the first problem of the homework because I didn't ask a problem in the exercise just like I did on the homework, okay? So I'm giving you the graph of a function. This is a parent function. You already knew this one. This was what? Is this dabbing? Is that what this is? Okay, we knew that one already, okay? So what are these points that I'm seeing? Let's identify some points. What are these points I see on the graph of x? What, -4? So -4, 0. And it looks like, what, -3, 1? And what, 0, 2? And 5, 3. That looks like all the points that I have marked out for you, okay? Those are points on F. Now, before I even draw the graph, what are the points that have to be on the inverse? 0, -4, 1, -3, 2, 0, and 3, 5. Those points have to be on the inverse, okay? So I can graph the inverse now. So just by looking at those points. So those points are what? 0, -4, which is right here. 1, -3, 2, 0, and 3, 5. Okay? So what do I see this function doing is this. Turn your head to the right. Does it look symmetrical? Mm-hmm. It does, okay? So now, domain and range. We've been working on this for quite a while. Look at the function f. F is this original function that was in black. What is the domain of that function? Domain, I start traveling on the x-axis from left to right. Where do I get my first x value? -4. So this domain is from -4 to infinity. Okay, it starts at -4, goes to infinity. What's the range of that function? Where do I go for range? The only time you're allowed to travel where? On the y-axis. So if I start down here, I don't see any values of that original function until I get to what? 0. So what's the range? 0 to infinity. Pardon me?
On the range, you go back.
Okay, the range is the only time I'm allowed to travel on the y-axis. This original function in black. I don't see any values in that function until I get to where? 0. That's the first time this function has a value. Okay? So its range is 0 to infinity. Yes? Yeah, the black one is the original function. This is f of x, and then this one is f inverse of x. Okay?
So like the range is where you start.
It's where the y value is the interval of y values this function has. Now let's look at the inverse. What is the domain of the inverse? Okay? So the inverse is drawn in what color? Green. So the inverse, where do I see my first x value? 0 to infinity. So the range of the inverse is from 0 to infinity. No, excuse me, the domain of the inverse from 0 to infinity. Okay? Now, let's look at the range of the inverse. To find the range of the inverse, where do I start? Down here. Where do I see my first value on the green graph? -4 to infinity. So, -4 to infinity. What do you notice about those guys? Yeah, they're inverted. Do I expect that? Yes, because what's an inverse? It's just the switching of the roles of x and y. So it makes sense that the domain of f should match the range of the inverse. The range of f should match the domain of the inverse. Okay, it sounds complicated, but all that's happened is x and y changed roles. So this shouldn't be a surprise to us. Is the inverse a function? Why do you say no? If it's not a function, I need to be able to draw a line, a vertical line, and it needs to cross that green graph more than once. Is there any way to draw a vertical line that crosses more than once? No. So it is a function. Yeah, the inverse. I'm asking about the inverse. Is the inverse a function? Okay. There may be where I'm asking you, is the original a function? Okay. But graphically, the way you tell, so for example, if I ended up with something like this, if I had a graph that looked like this, would that be a function? No, because when I draw a vertical line, it crosses more than once. So that would not be a function. Okay? So real quick, I think that takes you through starting how to get through the homework, finding inverses. Yeah, that's all good. And yeah, we should be good. Okay?